As you may already know, we will be talking about containers, all type of the containers. Um, it might be the first part of the webinars in regards to the containers because the team is really deep, and I'm quite sure that we won't be able to cover that one just for the one webinar because it's a lot to discuss and to share knowledge. Um, so I guess I can start with, and going further, basically we can see the first slide, and I just want to talk about the containers a bit, why you should use containers or why you should consider to use the containers in general, and how they are working. And in the simplest term, containers is a wrapper that allows software to travel between operating environments. Oh, I just want to mention that we will have a question and answer block in the end of the webinar. So if you would have any questions, I'll be glad to answer them there. And I have been talking about containers in general. So container technology greatly speeds and enchants cloud computing development, the buzzword that is really popular right now. And cloud computing companies, they hail containers as powerful tool for developing, managing, and migration application and software components from one system or environment to another. We will double check, is that the truth right now, and is containers really that necessary to have in every environment? We will talk about containers versus VMs. What should you do? What should you choose? And in the end, we will double check which type of the containers are available right now. Why would you like to have something as Docker, for example, maybe not like LHD or LHC, for example? Uh, so we definitely will discuss that a bit deeper later on. Right now, I just want to focus on what is container in general. And as I mentioned, so the main thing about container is it basically creates a sandbox. And sandbox is environment that basically separates application from others in the same environment. And this abstraction basically it creates an abstraction. Thus, the process ensures that the software code doesn't connect to other virtualized spaces and systems. And containers typically provide a library of content and tools, usually available via toolbar. So that's mean containers do not have any direct connection. Basically, application inside the container won't have any connections um, going out through that container. So it's basically granular. So if you would like to switch the environments for testing purposes, for example, or for R&D purposes, for example, you can just drag the container from the environment and just use it on Python 2.0 instead of using that on Python 3.0. And the results will be just same because you'll basically just eject the container. Containers can be deployed in one of two ways: by creating an image inside a container or using a pre-made image. There are different than virtual machine workloads. That's easy enough to realize. And I would like to talk a bit basically why we need that containers. Um, to do that, I would like to show you this slide and basically show you the differences. I'm quite confident that 90% of you already know what is VMs because yeah, we talk that through all day, right? We are working with that, and I'll just go through really fast. So the benefits of the VMs in this case, from my standpoint, so that's might be not like the overall thoughts about VMs versus containers. That's just my experience. So the benefits of the VMs. All OS resources available to the application. Quite established management tools, I guess. and stable security tools. That's what I have seen kind of the differentiator. And also there is some application that really not likes being inside the containers, but we will talk about that later on in a second. When it comes to the container itself, basically container sits on top of the physical server and its host OS, typically Linux or Windows, whatever. Each container shares the host OS kernel and usually the binaries and libraries too. Shared components are read-only. Sharing OS resources such as libraries significantly reduce the need to reproduce the operation system code and means that a server can run multiple workloads within a single operation system installation. Containers are thus a lot faster, and the size of a container is really just a few megabytes to start with. If we would compare a container to the VM from a boot standpoint, you will need at least a few minutes to the VM to be up and running, even if we're talking about like SSD, for example. For containers, it's a matter of seconds. And that's basically the main difference, light-wide, and basically simplicity of using the containers. Furthermore, if we'll talk about like Dockers and stuff like that, they're making life even like easier, I would call that. So you can just create a container for one exact application. No need to create some sort of a hypervisor, then install that guest OS exactly for each VM, and then install your application there. So if you can, and if you know that, hey, okay, my dev team will do the code exactly on this application, so that's a lot easier to just create that containered application that will allow your team to basically do all the required actions within that container. Okay, going next. So benefits of the containers, they're pretty logical. I mean, so you're reducing IT management resources because virtual machine, as you can see over here, so we will have that hypervisor, and then we will need to specify the amount of compute resources for every VM. Over here, when it comes to the containers, if you want to um, utilize some sort of like, for example, you have 16 GB over here and you have 16 GB over here. So you assign 4 GB of virtual memory for a first VM and 4 for second one. Over here, you're not assigned any VM to these applications. They just take whatever they need. However, you can limit that one. We will talk about that later on, but in a nutshell, over here, you need to like plan for that capacity. In this case, it's kind of more flexible. So you can use, every container can use any amount of resources that is allocated to this server. So that's basically the main difference between compute and storage allocation for the containers and VMs. Going next, we do have basically free, not really like free, but two big ones, as Docker and Linux containers. Oh, that's like, hey, over here, it should be up. Okay, oh, give me a second, I'll go back a bit. Okay, so that's LXC, LXD, and Docker. So I'll start with LXC and LXD. This one, LXCFS, that's basically a file system that's being used in LXC containers. Yeah, so when it comes to the choosing the right container, it's come down to the skills that you do have right now with the containers, the tasks that you want to accomplish without the containers, and pricing. So I would say LXC or LXD is cool feature if you have been already inside the container world. So basically, LXC is kind of well-known set of tools, templates, library, and language bindings. It's pretty like low level and very flexible. and covers just about every feature that you can think on upstreaming from the kernel. So basically, it offers a completely fresh and intuitive user experience with a single symlet. And if you do know that symlets, you can like really go up and running and spawn in multiple containers within one scheduled task. It's easily done. I won't go too far ahead, but I would say Docker might be a bit easier to start with. There is quite a few good libraries for that one, and Docker in general. Um, as for kind of comparison, I would compare that like Docker would be Hyper-V in virtualization world, and Linux, LXC and LXD would be maybe XAN server. So they would require a bit more knowledge to start with. And then if you do have that knowledge, they are a lot more customizable and kind of more personalizable, I would call that. So basically, LXC is OS level virtualization technology that allows creation and running of multiple isolated Linux virtual environment, VE, if I'm not mistaken. They can be ran on a single control host, and these isolation levels or containers can be used to either sandbox specific application or to emulate an entirely new host. LXC uses Linux C groups functionality, which was introduced sometimes in version 2.6, I believe, and that allows host CPU to better partition memory allocation into isolation levels called namespaces. And you can think about LXC as a supercharged ROT on Linux. It allows you to not only isolate applications, but even the entire OS. Its helper scripts focus on creating containers as lightweight machines, basically servers that boost faster and need less RAM. As I mentioned, there are two user space implementation of a container. Each exploits the same kernel features. And I would say it's kind of more deep in tech, just going in regards to the installation process and some sort of the commands that LXC can provide you with. So I would say it might be the team for upcoming second part, just because it might be too technical right now. And if I'll go like really inside the LXC installation process, we might be just ran out of time. And I really want to talk about Docker a bit more. So I would say, yeah, let's keep to the Docker. Um, okay, Docker. So I guess everyone already heard at least the Docker. And the main difference between LXD and the Docker as a container will be easy seen. So over here you can see that's like infrastructure host operating system, and that's a Docker. If we would can like tackle this from virtualization standpoint, it's like hypervisor for the containers. If we would do the same for the Linux, for example, we will still need some sort of the daemon over here to power up the VMs. So basically Docker is one of the best to start with, um, lightweight and robust solution right now. One drawback that I have seen through my experience is it limits your ability to customize the interface in regards to the installation process, but that's not really something that you could see if you would start just start with that. And from what I remember, it's the only container runtime that has been validated by NIST for its encryption. And since containers, they do have really like some issues with encryption and stuff like that. Oh, I just see someone is saying like lost audio. Hey guys, can you hear me? Or that's my mic is kind of like dropping me from a bridge? Yeah, I just see someone definitely can hear me, but I don't know, it's like a common issue or not. Okay, I guess. At least someone can hear me. Okay then. Um, and yeah, we have been talking about Docker. So Docker, previously called .cloud, was started as a side project, and it was like 2013 from what I remember, like maybe 10 years ago. And Docker act as a portable container engine and package it, and what it does basically is just package the application and all its dependencies in a virtual container that can run on any Linux server. So basically, we can use the Docker container as reference to some sort of the hypervisor level. So I would say, yeah, I do see that guys can definitely hear me. Okay, cool. So that's not issue on my side then. So Docker is some sort of hypervisor that has standards, and every container basically can work fine with, if we're talking about Windows environment for sure. And going further, Docker can offer some kind of unique features, and I would like to mention portable deployment across machines. So you can use Docker to create a single object containing all of your bundle application, and this object can then be transferred and quickly installed onto any other Docker-enabled Linux host. So that's mean that you can scale well, and you basically can just drag and drop your containers through the environment. That's really cool, because if we would talk about LXD, you would need a lot more actions to kind of achieve that. Going next, we do have versioning. So Docker includes Git-like options for tracking the version that have been succeeded. And you can see basically the difference between the patch notes. So I would say just in general, Docker do have kind of more, uh, Docker offers more availability in regards to the viewing of the events, of the tracking. Their support team is great, and community version is a lot better than we would go about LXC, for example. Um, Also, I would like to mention shared libraries, and I know that LXC can do that as well, but there is like and then there is a lot of articles right now on the internet about shared libraries and why and how Docker is doing that. I would just mention that it's really great option for cloud computing, for AWS, for example, or for um, hey Andrew, I do see your question. I'll answer all the questions because I have already like 15 questions, so I'll answer every question in the end. Um, and so I have been talking about AWS component of a Docker, and that availability to move the VMs and containers for the environment is really crucial when it comes to the cloud. So AWS do have that availability to provide the shared libraries. So you can do that through the whole compute layer. Going further, we have the last one and the last type of the container, and that's Windows Server containers or Hyper-V containers. So I would say it's not like two different type of the containers. That's more Windows Server containers that can provide you with Hyper-V containers. Because to use Hyper-V containers, you will need to install the Hyper-V role, and by doing that, you definitely would already have the Windows Server on it. And another thing that you should know is that there are two different container types. And Windows Server Container provides application isolation through process and namespaces isolation technology, which is why these containers are also referred to as process isolated containers. So they basically just isolate the process on the OS level. And HyperV isolation expands on the isolation provided by the Windows Server containers by running each container in a highly optimized virtual machine. And in this configuration, the container host doesn't share its kernel with other containers on the same host. So that's basically some sort of the nested containers. So for example, if we would compare that to regular containers, that's pretty much the same as you have created the virtual machine and then you install the virtual machine inside that virtual machine. That's over here basically what Hyper-V containers is doing. They install a container and they install the one container on the one kernel OS. So by saying that, I mean that there won't be any other containers that can work with the same OS kernel. And these containers are designed for a virtual machine that might have the multi connections simultaneously, and to be sure that there won't be any issues within simultaneous connection. They just allow us to have one container on one kernel OS. And I just want to mention that if we're talking about Windows container for Windows 10, for example, you can still use Hyper-V isolation to utilize the Windows Server kernel version and configuration. So that's mean that Hyper-V containers, they're the same level of cross platforms as the Windows Server containers. They are just more strict from resource standpoint. And running a container on a Windows with or without Hyper-V isolation is a runtime decision. And you can initially create the container with Hyper-V isolation and then later on add or not Windows Server container instead. Um, I guess for starters, because I do see that we have already got like 20 minutes down. I do have already like 4 or 5 parts for like the tech part, and I have already like 15 questions. I guess I'll go for questions now, and then based on what time it will be, we will either go to the tech side, like the creation, the containers deployment and stuff like that, or we will simply just create the second part of this webinar where me or one of my colleagues will show how to create the containers itself, and basically you will be able to see the difference between the deployment of the different containers types. Okay, let's jump right into the questions. Okay, how the resources. Okay, so the question is if we're talking about RAM resources, how will LXC differ between VMs? Okay, if I understood correctly, give me a second. I'll try to draw over here. Can you see my sketchpad? Uh, you should be able to see it, right? Yeah, at least I hope so. Um, so if I understand the question correctly, so just give me a second. For example, this is two OSs, like gas OS, and that's VM approach over here. Over here you have, for example, 4 GB of RAM for each of the virtual machine. And over here, that's, for example, you have 16 GB. That's your server over here, and this is the VMs. And you have assigned 4 GB of RAM, so over here you have left just with 8. but both of this virtual machine, they have 4 GB of RAM. And that's the VM approach. If we would talk about LXC, because Docker is a bit another beast, LXC or LXD approach would be a bit different. So over here, you would have 2 containers. Over here, you would have their shared resource pool. And for example, it's 16 GB. I'm pretty sure I have already mentioned that one. Maybe I've been a bit late, but what are containers doing over here? They are using as much resources as they would need. You can limit. So for example, if this container is rapidly accessed, and for example, it's using right now 8, it can be in use case. So you're not limit. These containers do not have their like strict limit from resource standpoint. So it can be from 0 to 16, for example. You can limit the resource utilization through that container just to be sure that one container won't eat all the compute resources that you have. I hope that answers your question. Okay, cool. No, you can PM me if not. That's absolutely fine. So I do see a question. Is it possible to make a container high available, like a Hyper-V cluster does with a VM? Yes, that's possible. They call it container clusterization. You can do that with LXC. You can do that with Docker. So that's not in rocket science at all. I guess we will cover that in upcoming tech questions. Oh, tech part of the containers. So that's definitely not rocket science. So if I would like to show that, give me a second. So they won't be like some sort of, so there will be a cluster. So basically, this is a containers over here, for example. This is shared library. This is daemons, for example. And over here, you want to, for instance, create the cluster through these 3 containers. And if you're talking about high availability, so in that case, you would need to have the failover. There won't be like some type of a failover, but there will be some sort of the replica. So for example, if one container over here would to fail for whatever reason, you can have a backup option over here that will start as soon as your container over here is down, and it will know when container is down, because as I mentioned to you, we will have the cluster containers. And yeah, I hope that answered a question. Okay, I do see a question. Docker versus any other containers? That's a really tough question. I mean, if you have no experience with any containers, then sure, like go for Docker. There is a lot of useful documentation. You can search for really good YouTube guidance. Docker is a lot easier from learning standpoint. Like you won't need to spend 5 years. I'm joking right now, but still a lot of the time to learn all the symlet to be really can easily manage the Docker containers. And when it comes to the features, so Docker right now, from my feeling, kind of provides that golden balance between features and money that it will require for you to obtain. So I would say Docker, then LXC, then May. Oh, and I just want to mention that if we're talking about the containers, that's not something that you should just, okay, I'm doing container for every VM that I want to. That's not the best approach to tackle this. So what I would recommend, first of all, double check, like, okay, why do I need container for this VM? So, well, as for recommendation, I would recommend to have the container, the application that you're dragging from you're dragging from one environment and then add into another environment, and you're doing that multiple times a day. So that VM requires some sort of protection for that environment, or not VM application, sorry. I just used to work with the VMs a lot, so I can sometimes call VMs container and vice versa. And VMs in turn, if you need something that will have their own OS and won't share any resources, that's where VM comes from. Like when we're talking about SQL Server, you don't want to have your SQL Server containered because you want essentially your SQL Server to not share any resources within partners in the cluster. So I would say you shouldn't go too crazy and just go all in on the containers. As for your question, I would say Docker is the good option to start with. If you already have a good, strong experience in Linux, you can check the LXD. They're a bit newer than LXC. They have updated the file system, so that might be a good option for you. Okay, cool. Okay, questions. Oh, I just closed the GoToMeeting for a second. Okay. Yeah. In general, the difference between I just answered that one, so I'm not going to go once more for the VM VS container. We have just talked for that. Okay, so the most questions are VMCS containers, Docker VS other containers, and okay, what network connections I do need to have the containers. I mean, there is no specific requirement for the network to have your containers, so it's more uh, compute requirement, I would call it. So if we're talking about compute, I would recommend having at least 64 GB of RAM and two 8-core processors. If we're talking about hosting from like something in range from 15 to 20 containers, um, you can even allocate a bit more for a future grow, because basically containers from resource utilization standpoint is pretty much the same as VMs. You just need to run some sort of analytical kit that allows you to realize, okay, I have that much right now. For a future grow, like 30% a year for upcoming 5 years, I'll need to have these much of the compute resources to run my containers. So yeah, I don't have like really direct answer on how much RAM or how much CPU you should have per one container, because it really depends on what you will run there. And from a networking, even that's even more, I would say, dependable on your environment that you have right now. So for example, if we're talking about standalone server from which you will run the containers, thus you won't need any outgoing connection. So all the connection will be just loop back and all your workers will work through the same server. Then you will just good with a 1 GB connection for front end. That's pretty much it. If you want to have something fancy, like create a cluster for the isolated location, for example, then you will need to double check that you have at least two 10G connections, just to that some sort of like migration. So if you can specify a question for more details, as for environment, like what are you trying to achieve and stuff like that, I definitely can advise something, but without that data, I'm quite sure I won't be able to recommend an optimal configuration. Okay, so the next question is, uh, Okay, so how many users can work for the one container? It can be multiple users, so you can assign the permissions to have or have multiple access simultaneously, or to have the single connection simultaneously. That's all customizable. So um, um, just think about containers as they would be VMs, but without hypervisor. So you can customize a lot of stuff there. So it's not like you just containered the application and that's it. There is just one point of enter and one point of exit. That's not correct. You just containered the application, but all that container is doing basically allows you to drag that container and that application from one environment and jack that to another environment. So all other tools and features are still there. So you can customize it how you want. And if we're talking about Docker, just wanted to mention that that's even more uh, kind of straightforward. And so there is less customization from overall standpoint, but it's a lot more straightforward on which button should I click to customize that one exactly. Um, okay, hope that answered your question. Okay, SQL Server. Oh, okay, I already answered on that one. So yeah, for SQL Server, I would recommend staying away from containers because first of all, you will need your own library for a single SQL Server. So that's something to consider. Going further, if you would have a container, for example, you will have the shared library, and that's not something that you would like to have for SQL Server. And frankly speaking, the containers, as I mentioned, they have been designed for the application that you um, can from time to time drag in from one environment, either for testing or for deploying purposes. SQL servers, frankly speaking, they are static. So there is no need to uh, kind of like try to add additional variables for your SQL server. Just do that. A good old VM like Windows 2016, 2019, what fills you best. Add a bit compute resources, do some SSDs there. I'm not seeing why you would like to have the container right now for the SQL server. Okay, so I just see the question is kinda okay. I'll answer that one. That one is also green. Okay, yeah, the questions is all done for now. Um, I guess if you don't have any upcoming question, we might call it a day and I'll start working on the second part. Maybe the next webinar will be about like really some tech details because we just got like 40 minutes. Um, oh, Steve is asking, can you make file server in a container? What are some great use cases for containers on the tester and development? Um, so Steve, you can do file server in a container. However, there is some drawbacks, I would call it. And so give me a second. I'll do the new one. So mainly what containers is designed for to spin up your VMs in not VMs but your applications within a second and make this VM reliable and make this VM kind of transparent to any environment there they would be ejected. So for example, this is your container and this is your environment. So the main reason why you're doing that, that's your second environment and the third one, for example. You can drag this container over here and the application inside the container won't realize that. And that's basically the main idea behind the containers at all. I mean, out of like really lightweight and blazing speed, that's the whole concept. And you can do like over here and up and running, application is cool, everyone is cool. When it comes to the file server, I'm having hard times thinking that you would ever need that sort of capability because basically file server is a big chunk of files. You don't need any performance out of here because that's not the application, that's not a VM. Um, I would say no. Yeah, I mean you can do that. I won't recommend doing that just because it's quite an overkill. It might be really complex because file server, they would like to grow rapidly from a storage part, and you would need to kind of specify a lot of the policies for exactly this container. So it might be kind of cumbersome. What are some great use cases for containers on the testing and development? Um, so as I mentioned, so I would say, yeah, so the main use cases for the containers, they are for sure testing and development, because developers, the guys, they are trying to make their application, their code transparent through every environment they do have in the company, for example. And exactly that's what containers provide them for. Going further for testing, that's also cool because environment change and you're basically you're testing the application and you're seeing the different results. If you're testing in a different Windows servers, even that can affect your test plans. So going further, containers really helps with that. And I would agree with you. These is two main use cases. Uh, okay, and yeah, so any upcoming questions? If I understand you correctly, keep your data in VMs and move your apps to containers. Yeah, that's the main idea. So basically, only one thing that I would like to aware you of, that not every application likes to be containered, and basically these type of the application, if you would do a bit of the Google, you will see like, hey, do not container this one or do not container this one. They are either like legacy applications and they have really bad time like being inside the container because they need some sort of OS connection. And we're talking about primarily Windows applications. I can create some sort of list, like of which applications you should consider to have on the VM because they are kind of like legacy and they are not really feeling great inside the container. Um, yeah, but in a nutshell, you're right. So you can keep the data on the VMs. If we're talking about VMs that is like still like databases, SQL servers, I would say these should be on the VMs as well. And the apps that would require some sort of transparency. Yeah, yeah, exactly. So if we're talking about scaling, containers can do that with ease. So you don't need to add additional resources. You don't need to recreate the VM, etc., etc. All you do, you just basically you have that application inside this container, and you need the exact same application with the same settings on, and this is for example like Windows Server 2016. And if we want to have the container over here, it would be just like C over here. If we would copy this application, like A, to this server, and this is for example 2019, this application most likely, I mean not most likely, but 90 or not, okay, not 90, 50-50, we will see some issues, like some errors, warning, and stuff like that. So what we're doing in turn, we're basically having that container, and we can simply transfer that on a new 2019 server, and it will be up and running 100% because we do have that container, and there is no OS connection to that, so nothing to kind of be affected from. And adding more when it comes to the scaling, you can add the same containers, or you can create a new containers with the same data for them within a minutes as a scheduled task with a Docker. So that's really easy. Okay, cool, cool, cool. So do you have any questions, guys? Okay, I'm not seeing any new questions coming. Um, and that's mean I can say thank you all for coming. That was a pleasure to speak with you. And I hope I'll see you next time. And if you would be interested in seeing the second part with more technical stuff there, you can ping our email box and we will be definitely taking eye on that. Uh, keep safe. That was a pleasure to speak with you. Goodbye, everyone.